sequential estimation type of the equalizer could be estimated channel profile. Right? This is an optimum receiver in the legacy structure in time domain only. But we can replace array antenna, widened mass diffuser in time and space domain. Like this. What I said that such a array antenna which has a multiple delay line, it's called a tapped delay line type of array antenna, TDL array antenna. Could be a space-time domain widened mass filter for maximizing the signal to noise ratio. Against the noise factors, we emphasize the signal level, right? And then we introduce a beta-B type of the equalizer. Yeah. And then the total performance. You know that it's a SNR, EV over 0, and the bit error rate. Typical conventional legacy beta-B decoder like this, but a space-time only like this. That means the same bit error rate 10 to the minus third is about 4 dB gain. That's also already applied for the 3G mobile phone or base station. Yeah. Like that. So the theory is very important. Again, I'm originally a theorist, but I also thinking how to apply for the individual use cases. I think in both, because my student working in many different places, even start working somewhere, like a company, keep important position. I wish the case of the common theory applied for the different use cases. I see them in the cellular systems. It's a base station side, and then this is a mobile station case. And then both sides are MIMO antenna prepared, and then it's more like a TDL type of array. Not just a simple one antenna wings, multiple delay line also set up. Right? And then I also thinking more application. Base station has a more bigger size, and energy can be supplied by the battery, not battery, it's a real cable energy supply. But on mobile side, mobile terminal should be compact and also battery operated. That one, we bias more complexity to the base station size. Because in total transmitter, total transfer function is this transfer function times this function and this function. All together common. The complexity should be biased to the base station side to make a simple hardware in the mobile terminal. Right? This is a case of the uplink. Okay. Of course, the downlink case also, when we transmit the signal, we also make more complex space-time filter in the base station, and then minimizing the mobile station complexity. This is what I said. The theory and the application, you have to think about both. Altogether, cellular systems, conventional time domain only the equalizer could be extended to the space-time domain equalizer, and then the optimum receiver. This is an uplink case. And then the downlink case, still the time domain equalizer, but it's a pre-coder. Yeah? That means equalizer, pre-equalizer before transmit. And then altogether space-time pre-equalizer, pre-coder for the equalizer. And then altogether the cellular system could be a more balanced in a sense of the complexity imbalance, the bias to the hardware in base station. So, the theory, if you have an interest, you can read the book I published about that. Yeah. And then the case of the 3G CDMA case, space-time domain structures, like this. You know that this is a 360 degrees. We have a sector, 4 sectors, right? And then each element antenna has a sector antenna. This subset is focused to the sector 1. This set is a sector 2. But too complex to make such a sector antenna by some subset of the array, subarray, like this. Yeah. Instead of such a sector antenna, we make such a small size of the subset of the array. And then it's like this. You know the 2 layers. This is originally the sector antenna. But instead of the sector antenna, we use a small set of the array antenna. Each subset has a, beam forming to the sector 1 and the sector 2. Actually, the same structure of the antenna. Only the antenna wave set is different. That means we commonly use a totally 6-element antenna for the 4 sectors, which has a parallel antenna waves. It has a different set. Yeah. And then the total antenna size will be minimized. Like this. Only the 6-element antenna, which are the parallel set of the antenna's weight for individual sector 1, 2, 3, 4. Yeah, it is much low cost and compact than the case of the hardware sector antenna case. Like this. This is also the creation of the research, meaningful for the practical use. Yeah. If you get a good position in the company, then the theorist should also think about what's the advantages of the exact application. And then also, even in you wish to working in academia, like a professor like me, the professor also have to have a more researching grant, right? Not only just a government researching grant. The company also pay me a lot because my technology is very useful for the practice, right? And then I have so many researching grants from all over the world in the industry, like that. So please think about both common basic theory and a very wide range of application and a business model. That's what at the beginning of this lecture I told you. Most of the case, but every week I requested the audience, students, that if you studied about array antenna today, and then till next week, you'd better to create some new business model, how to use this theory to the practice. If you provide a good business model, I myself funding to start business. We start up a company with you, or I can also introduce your technology or business model to my associating company or my own company. I'm a CEO of the company as well, right? And then it's more practice. You see, I had in the break time, Indonesia, even you got a PhD degree, less chance to get such a good job because R&D section in this Indonesian industry not too much, right? But you see that if you have such a business model together, no need to work only in Indonesia. You can also invite you to Japan or Finland or US or Canada because they're more practically important. And then you appeal your capability, your balance, both theories and the practice. And then you could be a CTO and a CEO. Yeah? Or you can be a great professor. Or both. It's true. Because myself, I do it. Yeah. yeah, each business has more income. 3, 4 times, 5 times salary than the usual professor. It's true. But I physically tired.